here's the $1,000,000 question, kids. Where am I actually going to use right triangle trigonometry, right? Like, I mean, I know math class, but what about in real life, you know? Jenny, are you wondering that as well? Yes, you are. Okay. Jenny and I use this all the time. Okay, first off, Vanilla Ice is trying to figure out whether or not it is safe to cut down a tree on his newest investment property, right? He flips houses in the Palm Beach area in Florida. Alrighty. He stands 70 feet from the tree and observes an angle of elevation to the top of the tree to be 54 degrees. Now, there's a fence 100 feet away from the tree, which is the direction he plans to have that tree fall. Is there enough room to do this, or should he figure out another plan? All right. Perhaps we draw up this wonderful scenario here. I'm gonna pause the video for that. All right, so we've got this lovely tree here. Okay, I didn't draw a palm tree. I decided to go with a regular old, like, you know, tree from around here. All right, and then he's standing 70 feet away, and then he observes an angle of elevation to the top of the tree to be 54 degrees. So let's go ahead and draw that in here. Watch this. Fancy ruler time. Pew, 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 pew. Okay, so he observes this angle. Let me fill those all in. All right, boom. He observes an angle to the top of that tree. All right, and keep in mind, this is from a horizontal vantage point. There we go. So what ends up happening here is we end up creating this right triangle within a wonderful math problem. Okay, let me get to 90. There it is. And then let me scooch that over. Boom. So we create this nice right triangle within it to help make sense of our world, right? I'm using math to make sense of my world. You might think it makes less sense, but I assure you it does not. Well, maybe. All right. So I got a right triangle. My angle of elevation was 54 degrees. That's a terrible 5. Let me try that again. There we go. I like that 5. I like that 5. All right. Now, we want to know, is there enough room for this tree to fall from this fence that's like, you know, maybe there's a fence right here. That fence is 100 feet away, right? 100 feet away. Fence. It's a beautiful fence, isn't it? Okay. All righty. So what measurement am I trying to figure out here from this right triangle? I know that this side right here is 70 feet. That's my adjacent with respect to that 54-degree angle. Do I want my hypotenuse or do I want my opposite? Well, if I'm going to cut down this tree, it's oftentimes thought that, like, I need my hypotenuse. But really, we're trying to find the height of that tree because the height of the tree is going to be how far it falls, right? The height is when it falls down, okay? So I really want this side right here, which is my opposite. OPP, yeah, you know me. All right. So if I want my opposite, I have my adjacent. I know my angle. Time for a little bit of SOHCAHTOA action, if you will, right? Now, I'm going to be using my tangent function. I'm solving for a side, so I'm using regular trig, right? So I'll have the tangent of 54 degrees is equal to my opposite side over my adjacent side. And this one actually is the very favorable, wonderful, fantastic type where it's just multiplied by 70 on both sides. And in my calculator, I'm going to type in 70 times the tangent of 54. Let's pop that bad boy up, shall we? I think we shall. Boom. Better turn this bad boy on. Probably turned off to save battery. Okay. So I've got 70, tangent, 54. Woo. Closes parentheses. You know what I'm saying? All right. And I get 96.3467. Lovely. So that means 96.346, 96.35 feet. One tick mark is feet. All right. Cool. Awesome. Fantastic. Wonderful. So that is the height. Is that the total height of the tree? Perhaps there's something else we should take into account here. Now, in a math problem, say on a test or a quiz or whatever it would be, I would prompt you with this information. But what are we not taking into account right now? Perhaps the height at which Vanilla is observing from. Maybe we hit the internet, figure out what his height is. All right, there we go. Vanilla Ice's height, 6 foot, 0 inch. What a beautiful, wonderful number. So easy. MC Hammer, also 6 foot. Todd Bridges, 5'11", and then Eminem is 5'8". Perhaps they'll come up in later problems. So let's just go ahead and say that he's observing from that 6 foot mark. You know, really his eyes are going to be a little bit lower where he's angling from, but let's go with just 6 feet to make this a little bit easier. So what do we do with that information? Well, we're going to need to add that to the height that we've already found. And now I'm going to have 102.35. Now, I know we always go by yo-ro. You only round once, right? Don't round throughout the problem. But because I'm only adding 6, rounding that 96.35, doesn't really matter in that context, right? That's not going to change things. I'm not multiplying, taking trig functions of numbers and things like that, right? So overall, 102.35 feet. So is there enough room for this to fall towards that fence, which is 100 feet away? New plan. Needs a new plan here. I would tell you, even if it was like 96.35 and I was doing that, I'd be like, bro, that's a little bit too close for comfort. I don't think I want to let that fall near that thing. But as we can see, once we added that height in, definitely over 100 feet, figure out a new plan. All right, that was dope. Vanilla, I hope you enjoyed. I'm sure you're watching this. Riverdog Jenny, did you enjoy it? Yeah? Okay. She did. All right, see you guys later.